Hello and welcome back. So in the last episode, we were discussing on the topic 2D viewing. So in this episode, I'm going to discuss on a new topic, that is clipping. Okay, so let's see what is clipping. Okay, any procedure that identifies those portions of a picture that are either inside or outside of a specified region of space is referred to as a clipping algorithm or simply clipping. So the region against which an object is to be clipped is called a clip window, and it is a process of determining the portion of a primitive lying within a region called clip rectangle. So an object is clipped in a clip window, and a primitive lying within that region is called a clip rectangle. So we are moving on to some basics of clipping. Okay. So sRGP, that is Simple Raster Graphics Package. I hope you remember what is sRGP. It offers two methods for clipping, that is pre-clipping and then scan converting, and doing clipping during scan conversion. That method is known as scissoring. So while in scan conversion, we are clipping or we are cutting the edges. Clipping is we are cutting off the edges that is lying outside the clip rectangle. So that is known as scissoring. So applications of clipping include extracting part of a defined scene for viewing. Okay, we are extracting that part for viewing, and identifying visible surfaces in three-dimensional views. That is another application. Then anti-aliasing line segments or object boundaries. Okay, then creating objects using solid modeling procedures and displaying a multi-window environment. And the last application is drawing and painting operations that allow parts of a picture to be selected for copying, moving, erasing, or duplicating. So for the viewing transformation, we want to display only those picture parts that are within the window area. Everything outside the window is discarded. Okay. Now our first type of clipping is point clipping. Okay, let's see how we are doing the point clipping. Okay, assuming that the clip window is a rectangle in standard position, so we have a point P is equal to x comma y for display. Okay. Now if the x coordinate boundaries of the clip rectangle are at x min and x max, and the y coordinate boundaries are at y min and y max, then four inequalities must be satisfied for a point P equal to x comma y to be inside the clip rectangle. Okay. Let's see what are the four inequalities. That is x min less than or equal to x less than or equal to x max, y min less than or equal to y less than or equal to y max. So if any of these four inequalities is not satisfied, the point is clipped. That is, the point is outside the clip rectangle. So we have to clip it, and we have to only view the portion of the point which is inside the clip rectangle. Okay. Now let's see the next topic, that is line clipping. Okay. That is clipping lines by solving simultaneous equations. Okay. Let's see how it is. So to clip a line, we consider only the end points. That is, we need not consider the large number of interior points which are exclusively included in that. So if both the endpoints of a line lie within the clip rectangle, that is, if both the endpoints of a line lie within the clip rectangle, then the entire line is within the clip rectangle and is trivially accepted. That is this line. The line called AB is supposed to be trivially accepted because both the endpoints are inside the clip rectangle. So this rectangle is known as the clip rectangle or clip region. Okay. So this is the first case. Now I'll move on to the next case. That is, if one endpoint lies inside and other is outside, the line intersects the clip rectangle, and we must compute the intersection point, that for example CD. So this is the example. So C is in interior and D is outside the clip rectangle. So we have to clip the rectangle and find the intersection point. So we are clipping it as on D dash. Okay. Okay, now if both points are outside the clip rectangle, the line may or may not intersect with the clip rectangle. For example, GH and EF. So we need to further calculate and determine where there are any intersections. So GH is this line, that is both the lines are outside the clip rectangle, but it doesn't intersect the clip rectangle. And EF is this, but here also both the endpoints are outside the clip rectangle, but it intersects the clip rectangle. So we have to do further calculations for this. Okay, so we'll see what it is. So the brute force approach to clip a line that cannot be trivially accepted is to intersect the line with each of the four edges of the clip rectangle to find the intersection points. Okay, so we are finding the intersection points, see, like this. E dash and F dash, we have clipped the line intersection points on the clip rectangle itself. So for each line and clip rectangle's edge, we take two mathematical infinite lines that contain them and intersect them. And we test if the intersection point is interior. That is whether it lies within the clip rectangle. For E dash, it lies within the clip rectangle, and F dash also, it lies within the clip rectangle. So here we solve two simultaneous equations using multiplication and division for each edge line pair, but this equation deals with only infinite lines and it does not consider vertical lines. So a parametric formulation for line segments solves this problem, that is x is equal to x0 plus t into x1 minus x0 and y is equal to y0 plus t into y1 minus y0. So that is the equation describes x comma y on the line segment from x0 to y0 to x1 y1 for the parameter t, which is within the range 0 comma 1. So this is how we can clip lines by solving simultaneous equations. So these are the simultaneous equations which we are using to solve line clipping. Okay. Now we have an algorithm based on that is Cohen-Sutherland line clipping algorithm, which I will be continuing in the next episode. Okay. Till then, thank you so much.